on the very, very bottom, either on the front or back, writing small, this is what I want you to write down from left to right. Remember, we're dealing with functions that are fractions, and I told you yesterday, whenever you're doing stuff to the top, that's what kind of information on the top. Starts with an R, and then an O, and then another O. Roots, that's right. So anytime you're doing stuff on the top, you're dealing with root information, or solutions, or zeros, or x-intercepts. Somewhere on the bottom of your SHRATEY cheat sheet, on the front or back. I know it's not a lot of room, and you're going to have to write small, but I think it's important exercise. And then, so roots are on the top, and what kind of information is on the bottom? Starts with an A, and then has an S, but is classroom appropriate. Asymptotes, right? English is all around us. We can't escape it. Roots and asymptotes, okay? And then I said yesterday that anytime you're doing math on the top, you get some information. Roots are points. And so anytime you're doing stuff on the top, or with the information in the numerator, it's point information, which means you need to write it as an ordered pair, x, y. So stuff on the top is roots. Those are points. You need to write them as x, y pairs. What's the stuff on the bottom? Lines, right? Those are asymptotes. So those are lines, and they need to be written like this. X equals some number. So we already said that those are asymptotes, but specifically, what kind? When you're talking about the stuff on bottom. The ones that go up and down, the vertical ones. These are vertical asymptotes. And vertical are written x equals a number. Horizontal, which we'll talk about later today, are y equals a number. And so then when you get to the T step in your SHRATEY, that also is talking about the stuff in the top and the bottom. The T for the top stands for what? Tangent, and on the bottom is together. Before you can decide if your stuff is tangent or together, you're looking for what that's happening for that T step. Squared. You're looking for squared factors. So if you're looking at the stuff on top, which is about your roots, if you have a squared factor, that means the T word, whatever it happens to be, occurs. And the T for the top is tangent. In last semester, we didn't call it tangent. What did we call that? Bounce, right? So that means it's going to bounce at that root. So if you have a squared factor, the T thing happens, and it happens to be tangent. Well, if you don't have a squared factor, if it's not squared, then it's going to do not bounce. What's that called? Cross. And that's stuff we talked about last semester. So that's all root information, okay, with the T part. And then when you start looking at the factors for your asymptotes, same question. Is anything squared? So if you have a squared factor in the bottom, the denominator, so if you have a squared factor, the T thing happens. What's the T thing for the bottom? Together. And let me talk about what that means. I will show you. When we learned our parent functions on Monday, We talked about W over W. I'm making up stuff. We talked about 1 over x squared. Bless you. Now here's an example of a squared factor in the denominator. Let's look at the graph for that. Here's your asymptote. This is the asymptote created by that x squared factor. Okay, that's x equals 0. When I'm saying that the graph comes together at the asymptote, what I mean is this behavior right here and this behavior right here. Okay, immediately on either side of the asymptote, what's happening? Not anything out here on the left or anything out here on the right, immediately right here. This side of the asymptote and that side. This means coming together. So as the graph, the x values are coming in, the shape of the graph is coming together. So that's what the T thing there means. So let's look at what not together means, right? So if you don't have a squared factor, so not squared, means not together, it means opposite. And we can see that in the other parent function we talked about, the 1 over x. Here is the vertical asymptote that we get from the x on the bottom. And I'm looking at the behavior on the left side, immediately on the left and immediately on the right. They're opposite. This one's going in the negative direction, that one's going in the positive. They're going away. So together, opposite. Not squared, squared. So keep all that in mind when you're doing the T stuff on your SHRATEY. So that's everything I want to do to write down. So now what I want you to do is put your pencils down, or you can finish, unless you're finishing that. And I want you to just listen and watch me rework the problem from yesterday, because repetition is good for you. Repetition is good for you. So you have that? Can I change this? All right, so here we go. Hold on, just a second. Almost. Here we go. So we have this problem from yesterday. What does S stand for on your SHRATEY sheet? Simplify. So in order to simplify, you have to first be able to see what can be factored. And we said that your factoring methods are GCF. Always check for GCF first. Difference of squares, the cross method for trinomial, or grouping if you have 4 terms. So the top one is GCF. So you pull out your common factor. Can't factor that anymore. The bottom is a trinomial, so you do your cross method. What multiplies -3 adds to -2, and we said blah, 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 2, 2, 2, 2. And then we got this. Those are our factors, okay? There's nothing that's the same on the top and bottom, so nothing cancels out. And so the H step is where we get information if something canceled, but nothing did, so that's an NA. In fact, H is going to be NA for the rest of the week. We're going to do H on Monday, so don't worry too much about that. All right, R stands for what? Roots. Is roots the top or the bottom? Top. So the root step is you set the top equal to 0. The A step, you set the bottom equal to 0. That's for asymptotes. Then each of those factors get set equal to 0 and solved for. But here's what I need you to ask yourself on these parts. Once you find your 2 numbers for the root, you have to remind yourself, oh, the roots are points. Miss F wants me to write those as ordered pairs for full credit. Okay? And so you need to write these as XYs. So that means this. Oh, because I was not thinking. So there's that. So then we have those points that we can put on our graph. So there's your roots, 2 roots. And then when you go to A, I'm not going to set up the baby equations. I'm just going to save some time and do insider's lie. That's where insider's lie comes from anyway, those baby equations. And I've asked myself, are these points or lines? Lines. Do I need to write them as ordered pairs? No. They're good right here, just like that. And then they are boundary lines. They're not actually part of the graph. So when you go to graph them, don't make them solid, make them dashed, because they're just like placeholders, kind of. So there's this one and this one. All right, so far so good. Got some stuff on there. The T step is for the tangent together. I'm going to write it a little bit differently than I did yesterday. Yesterday I said, oh, look, okay, on the top nothing is squared. That means they're both not what? What's the T for the top? Tangent. So they're both not tangent. And I just wrote not tangent one time. The truth of the matter is, when you have multiple factors, one might be tangent and the other one not. You could have a combination there. So what I'm going to write today is, I'm still going to write not tangent, but I'm going to write it one time for this factor x and one time for the factor x plus 3, that they correspond. So the x factor is not tangent, and the x plus 3 factor also not tangent. So those correspond to the order that I wrote them above. Same thing with the bottom. For the T step, you're checking if anything is squared or not. X minus 3, not squared. X plus 1, not squared. So it's not what on the bottom? What's the T word for them? Together. So first factor, not together. Second factor, not together. Now, the thing I want you to understand about step T is I've been seeing some students today, they get that information for T and then they tell me, how do I put that on the graph? You don't, not yet. That's for later when you're trying to piece everything together. So just, it's helpful information, which we're going to use in a little while. So just let it hang out there. Now E, I need everyone to turn to the E section on your SHRATEY cheat sheet. And there's some words there that I'm going to have you find and box and circle, put stars around it, happy faces or crying faces, depending on how you feel about it. I don't really care what you write as long as you can find it. And these are the words. Leading terms. Find that in the E section and mark it up. Leading terms. The weird thing about the E section is that it's not very intuitive. You know, you can kind of fake your way through all the other ones if you've been paying attention. But for the E part, you just have to memorize how to get started. You get started by looking at the leading terms in the top and bottom of your original function. Leading term is the first term. So it means this. You go here. Those are the leading terms. You're going to just remove them from the rest of the function and write them down as a fraction. And then you're going to compare them to each other. This is the thing you're comparing. Are the powers the same? Or is the power on the bottom bigger? These are your two options. But yes, they're the same. And what does your table call that? Balanced. Okay. So if you're looking at that section of your table where it says balanced, it says you're going to find your horizontal asymptote. You're going to write it as y equals a number. Here's where you get that number. You get it by simplifying this thing that you wrote with your leading terms. In this case, it's just 1. You might sometimes have this. Like if you had 3x squared over x squared, these would cancel and your number would be 3, and that would be your horizontal asymptote. Okay? So this number changes from problem to problem. In this problem, it happens to be 1. And you need to write it as the equation of a line. y equals 1. And then you put that into your graph at y equals 1. So that step it's on you to memorize how to do that step. Once you do, it's easy. It's not hard, it's just remembering what to do. And then y stands for y-intercept, right? That is where the graph crosses the y-axis. On the y-axis, x equals 0 everywhere. That's why on your SHRATEY sheet it says plug in 0 for x. So you plug in 0 for x, you do math, and you get 0, 0 in this problem, which we already knew we were going to get because in this case the x-intercept and y-intercept are the same. It won't always be 0, 0, but it is here. So then you get through all your letters and you still don't have a graph, right? So you have to figure out how to start piecing stuff together. One thing I want to emphasize that I may not have done very well yesterday is this. The end pieces, the left and right pieces, will always have this basic form like the parent functions did. So this side will have that form, this side will have the form. The stuff in the middle, the two options for there, either it's bouncing or it's crossing through. But on the left and right, it's going to have these curves. So in this case, though, that's fine. It's going to have the curve. Here's what I don't know. I don't know if that shape is going to happen like this or if it's going to happen like this. Do you remember what I told you yesterday that will help me figure that out? Do you remember? What do you remember? I need to find a second point, right? I call that what kind of points? Starts with a T. Test points, right? All right, so I need a test point. And so then I had some questions say, well, how do you find the test point? Like, how do you decide which x value you're going to use? It can be whatever you want that's helpful. Like, for example, to figure out what the graph is doing on the left side, I'm not going to pick an x over here. I'm going to pick an x here on the left side. So it can be -2, -4, -5, -6. All you need is the second thing to start the shape of your graph. What I chose yesterday was -2. So I said, plug in -2 for x into your original function. Follow your order of operations. And then simplify. And I told you when you do that, you'll get -2/5. Okay, for your point. And that's all you need to figure out now what that left portion is going to look like. You put that point down, and now you know that this part of the graph is going to be below the horizontal asymptote. It's going to go like this. It's going to approach that horizontal asymptote there. Okay. And that's money, because now that I have one basic part of the graph, I don't really have to do too many more test points. For the most part, I can just use all this other information to deduce what the rest of the stuff is going to look like, to just figure it out using my brain. And here's what I mean. So this is all the way up to that first asymptote. Now I need to know what's going to happen on this side of that line. I have a point. I have one point. Which part of SHRATEY will tell me how the graph is going to behave right on the other side? Which letter? Yes. Which letter of SHRATEY is going to tell me what the graph is going to do right on the other side of the asymptote? T. That's right. So look at these things that we took the time to do on T. We said that this asymptote right here, x equals -1, comes from this factor, x plus 1. Well, what did we say about that factor down here? We said that when you're at that asymptote, the graph is not going to come together. the graph is not going to go the same direction on both sides. So I know this direction now. So if it's not coming together over here, it's going away. So instead of down, it's going to be going up. Okay. Because that's away. And then I know that eventually it's going to cross through this root. Now, here's what I don't know. I don't know if it's going to bounce at that root and come up, or if it's going to cross. However, I already did that work for myself here at the T section again, right? But that's root information. That's in the top. This root right here, the 0, 0, came from this factor. And what did I say about that factor down here? I said the graph is not tangent there. That means it doesn't bounce. So if it's not bouncing, it's doing what? Crossing through. And it's going to keep going towards that next asymptote. Okay, and this is the last piece of the whole thing. That asymptote at x equals 3 came from this factor, x minus 3. For that factor, we said the graph is not together. So over here, it's not doing this. That's together. It's not doing that. It's doing the opposite, which is up. Okay? And then we're finished with that problem. Any questions about anything out there? What we're going to do now is I'm going to give you the homework sheet. You're not packing it away. You're not taking out your phones. This is still lesson time. You're going to do the first problem. If you master that, you're going to try the second one. And then after some time, we will talk about the first one together. So it's not bathroom time. It's not phone time. We're still working. Not yet. Nope. So do the first problem absolutely for sure. And if you get that one real easy, start the second one. For the S step, something I want everybody to see here is that you cannot simplify by doing this. That is bad math. It feels like you really should be able to do that. But when you cancel factors, remember what the word factor means. Something, it's stuff that's being multiplied together. So if it's not being multiplied, it's not up for canceling. These are being added and subtracted with other things. So they're not factors. So instead, what you're going to think is that this is a grouping and this is a grouping. And that's what you're dealing with, okay? So you can't, and neither of them are the same, so they don't cancel. So these first two steps are not going to happen. So R for the root. Root is the top, A is the bottom. So R means you're setting the top equal to 0 in solving. R is roots. It's a point. So you're going to write it as a point. So I was soft a moment ago when I didn't take Paulina's phone, but I know some of you are on your phone right now. Please put it away. I'm not going to turn around, and I'm going to give you 2 seconds to do that. I should not be inconsistent. Then people get mad at me when I go to take the phone the next time. But you didn't do it for so-and-so. A is for asymptotes. It's the bottom. Set that equal to 0. That's a line, so you can keep it like this. X equals 1. Good, very good. T is for tangent and together. Remember, you're looking for if your factors are squared or not. X plus 3, not squared. So it's not, what? What's the T for the top? Not tangent. X minus 1 on the bottom, not squared, so it's not together. And there's nothing you can do with that right now except wait to use it later. There's nothing to graph or anything from that step. Use for end behavior, it's your horizontal asymptote step. It comes from the what's that I had you box and put stars around. The leading terms. It's the first term on the top and bottom. Are the exponents the same or bigger on the bottom? The same. That's balanced. That means you simplify it. This is going to give you 1. You write it as a line, y equals 1. And the last step is your y-intercept, where it crosses the y-axis. That means x equals 0. You plug it in. Remember, when you're simplifying fractions, you need to do all the math on the top first. It's not very much math here. All the math on the bottom. You get the you get the -3. This is a point. You write it as a point. X was 0. Y is -3. So question for you. I have a question. Why don't I need to do a test point here? I already have 2 points on the left, on one side. If this second point was over here, it wouldn't be doing me any favors. I would need a test point. But 5. Which ones are you not going to do? Did you hear me? 61 and 65. I'm going to put the key in Google Classroom. It's also in the back if you have time to take a picture of it. Have a wonderful day.